So what I was asking you guys to do was to identify whether something had a general limit, whether it was continuous, and whether it was differentiable. So a function has a general limit as long as our limit from the left is the same as the limit from the right. So that means something like this. Here I've got two functions. So whenever x is less than 2, I've got this red line, which is y equals x plus 2. And whenever x is greater than 2, I've got this blue line, which is x squared. Okay, so if I was going to draw this out, it would look like this. And I'm going to freeze shot this for a second. This won't show up on a graphing calculator, but I am undefined at the point x equals 2. Because that doesn't go into either of my equations. So I'm going to redraw this really quickly. Okay, we actually have an undefined point here. Okay. Okay, so at x equals 2, we're undefined, right? So my limit from the left is what happens if I get really, really close to x equals 2 from the left. So that's going to look something like this. As I get closer and closer and closer to x equals 2, what does my y value get close to?
4.
4. Okay, what about from the right?
From the right is still 4.
Still 4. Okay, so because that limit from the left is the same as my limit from the right, my general limit is 4. Okay, in order to be continuous, wrong one. In order to be continuous, I have to have a general limit, but when I plug it in, I also have to get the same y value. So that looks like this. I'm going to zoom in just a little bit. In order to be continuous, my limit from the left has to be the same as my limit from the right. And when I plug it in, I have to get the same result as the general limit. Okay, so for our function we just drew, we are not continuous. Why am I not continuous?
Because there is a general limit, right?
There is a general limit, you're right.
Because there's no removable?
Okay, so there's a removable discontinuity, which means we are not defined at x equals 2. We don't know where to go. In order to be continuous, x equals 2 must be 4. Because we have to be the same as the general limit. So if I was going to draw another point, we'll say somewhere up here and fill that in. If x equals 2 is equal to 5, that would also be not continuous. This is discontinuous because the line does not pass through the point. But I do have a general limit. So as I get close to x equals 2, the y value gets closer and closer to 4. Okay, so I'm going to change this around. And this time I'm going to fill in this point. So now x equals 2 is 4. And we are continuous. Okay. In order to be differentiable, we have to be continuous, which means we have a general limit. The limit from the left is the same as the limit from the right. When I plug it in, I get the same result. That's what I needed to be continuous. And one more condition. This is new. The limit of my derivative must be the same from the left and the right, which means our slope has to approach the same value. Okay, so if I take a look at my graph, back here. Okay, what is the slope of this red line? X plus 2.
Is 1?
Slope is 1, perfect. Okay, what about this blue line? X squared. So this blue line, it doesn't quite look curved, but this is y equals x squared. So at the point x equals 2, what would the slope be?
x equals 2?
Yep.
Is it 0.5?
Not 0.5. What happens when you derive x squared?
2x.
2x. Okay, and then our x value is 2, so what's our slope?
X to the first power.
So if this is y equals x squared,
Uh-huh.
you told me the derivative then would be 2x. My derivative is a slope, so what is the derivative when x is 2?
X is
Yep. So I'm going to take my derivative, you told me is 2x, and we'll plug in 2. So what should I get?
mm-hmm. Wait, I don't get it. Why it goes?
Okay, I'm going to move the carrot stick. So this is unusual.
It's 4. It's 4,
Right. So my slope is 4 at the point x equals 2. So when you derive it, you get a general form. This is the slope at any x value. Then you can replace that x with any x value you want, and that will tell you the slope at that point. So my slope when x is 2 is 4. Okay, so our slope is 4. So from the left, if I get really, really close to x equals 2, my slope is getting closer and closer to 1. But from the right, my slope is getting closer and closer to 4. So because my slopes are not equal, we are not differentiable at the point x equals 2. Okay. In order to be differentiable at this point, my slope has to be approaching the same value from the left and from the right.
So the slope has to be the same?
Right. Okay, I'm going to give us another example really quick.
Ms. Brandon, how do you set up the equation? X less than 2, x plus 2 equals.
How do I type it in Desmos, do you mean? Or
like, how do you know that like what you're typing looks like the line shown on the graph?
I guess I don't understand the question. I'm sorry.
It's just like, how do you set up the function?
Okay, so I picked this function just so we could talk about it. But on the test, they'll give you different functions. So let me write this out in Word, and I'll show you what it'll look like on your AP test. So they're going to give you a function something like this. F of x is equal to, and we'll type in a bracket here, some sort of a matrix. And six. Okay, I'm gonna play with this just a little bit to make sure this works later. But okay, so I've got this would be 6. I want this to be 8, so this should be plus 2. Okay, we'll try that. So on your AP test, it'll look something like this. So they're going to give you a piecewise function, which is a function that's defined in a bunch of different pieces. So whenever x is equal to 3, we would use the top part. So y would be 6. Whenever x is less than 3, I can use this line. And whenever x is greater than 3, I can use this bottom line. So they'll ask you which of the following describes the function f of x, and then have a bunch of answers. So general limit at x equals 3. This is differentiable at x equals 3. And then give you like options A, B, C, D. This is 1 only, 2 only, 1 and 2 only, all of the above, none of the above. Okay, this is what it'll end up looking like on the AP test. So sort of like a multiple choice question. Let me zoom out so I can get all this in. Okay, so if I wanted to do this, how could I find out whether or not we have a general limit? So what has to be true?
The point you're meeting from the left should equal to the right.
Right. So if I plug in something to the left of 3, which of these equations do I need to use? The top, the middle, or the bottom?
Left of this.
Right.
The second one.
Second one, okay. So if I plug in x equals 3 into the middle equation, what do I get?
Is equals 8.
8. Okay, what about from the right? If I plug in x equals 3 from the right, what will I get?
From the right.
Mm-hmm.
So the third function.
Yes.
8.
8.
So,
okay. Still 8. So do I have a general limit?
no. This is your.
Okay, we do have a general limit because from the left and the right we're both 8. So because the left and the right were the same, I have a general limit.
But 8 is not. What is it? 8 is not less than 3.
When we're looking for general limit, I'm looking for an x value that is less than 3 or greater than 3. So if I'm less than 3, then my y value is 8. If I'm greater than 3, my y value is also 8. So as I get really, really close to 3 from both the left and the right, our y value gets really close to 8, right?
Mm-hmm.
Okay, but something weird happens if x equals 3. So what happens if x equals 3?
X equals 3 for which function? The first one?
So all of this is one function. This is f of x. So if x equals 3, which equation do we need to use? Top, middle, or bottom?
The top one.
Top one. Okay, so what's my y value when x is 3?
6.
6. Okay, that's not the same as 8, which we got from the left and the right. So this does have a general limit, but is it continuous?
It is not continuous.
Right, it is not continuous. Why is it not continuous?
Because the top function should be 8. When x equals 3, it should be 8, not 6.
Right. So in order to be continuous, when we plug in the value, we should get the same point as our general limit. So what we're getting close to from both the left and the right. Okay. In order to be differentiable, we must be continuous. So because we're not continuous, we know 3 is not true. We can't be differentiable either. In order to be continuous, we have to have a general limit. In order to be differentiable, I must be continuous. So we can actually check these in order, because if if the first one's false, if there's no general limit, then all of them are false. They can't be continuous or differentiable.
But when is the case that it will be differentiable?
Okay, I'm going to change our problem a little bit. So I'm going to change the letter just so later on, if people are watching this, they know what I'm changing the problem. So this is now h of x, and I'm going to change this to 8. In fact, I'm going to make this red just so people know that I changed that. Okay, so if this is h of x instead, I didn't change our limit from the left and the right. So do I have a general limit?
Yes.
Yes. What's my general limit?
8.
8. Perfect. Am I continuous now?
Yes.
Yes. Why am I continuous?
Because the function you plug in on the top function goes 8.
Perfect. So when I plug in the value into h of x, I also get my general limit. So this is continuous. Okay, and here's the tricky part. How can I tell if this function is differentiable?
Slope? Slope has to be the same.
Right. What's the slope from the left?
From the left, right?
Yep. What's the slope from the left?
Do you just plug in the number?
So you need to derive it because a derivative is slope.
Uh,
And then when you derive it, you can plug in the number.
for left is 2.
Okay. What about the right?
Right is 4x, but wait, this is it's 12, right?
Right. So is this differentiable?
No.
No. Okay.
Think so.
So this is not differentiable because from the left is a slope of 2, and from the right is a slope of 12.
Yeah.
Okay, I'm going to change this one more time. So I'm going to make our function, let's see, we did f and h. I'll make this j of x. Right, j of x. And this time I'm going to change our function one more time. And we'll say this is... what should this be? I want this to end up being 12. This should be 12. So this is 36, 38, and this is 18. This should be plus 20. Okay, I changed just about everything there, so let me highlight everything again. Okay, so new function. I'm going to double check, make sure this works really quick. This is 36, 38, okay, and this is... good. This needs to be 38 now. And... okay, I think we're good. Alright, so for the first one, do I have a general limit?
To 36. Yeah, yes.
Okay, I do have a general limit.
38.
Perfect. So from the left and from the right, we are approaching 38. What happens if I plug in the point?
It's still gonna be 38.
Still 38, okay. And the tricky part, what happens if I derive? So if I'm differentiable, I need to get the same derivative from the left and from the right.
X to 12. Yes.
Okay.
Now it's same. Everything's same.
Everything's the same. Okay, so this one is differentiable, and it is continuous, and it has a general limit. Awesome.
So Ms. Brandon,
Yes.
if I put this equation for the homework, then it is the example for differentiable, right?
Yes. This is an example of a differentiable function. Any function where you are continuous, you have a general limit, and your derivative is the same from the left and the right, is going to be differentiable. So an easier function to do, if you just wanted something that's differentiable, would be something like a straight line. A straight line is differentiable at all the points. So you'll need a piecewise function when you want something that is continuous and not differentiable, or you want something that has a general limit but is not continuous. But if you just want all three, then just make a function that's continuous. So if there's no breaks, there's no piecewise function. That should be
So this can
differentiable as well.
be. So I can just put this equation for all three reasons.
Um,
Uh,
well, this equation right now only works for it has a general limit, is continuous, and is differentiable for j of x.
uh,
Last time when we had h of x, h of x was continuous but not differentiable because the derivative was
uh,
different. And then f of
yeah,
x was a general limit but was not continuous.
yeah.
So let me draw these out graphically really quick. Jump back to Desmos. Less than 3, less than 3. This was... I've already forgotten. 12x.
For fx.
I'm going to do j of x. This is
Okay.
12x plus 2.
Plus 2x less than 3, and then 2x squared plus 20.
Okay.
And then x squared 3.
Okay.
There's a 38, x equals 3. We don't need that.
Okay. So I'm going to have to jump way up here because my graph is huge. Here's what my equation looks like. So I've got the point 338, and you can see my slopes look almost identical, right? It almost looks like my function is just continuing on. Even though this one in red is really a straight line, and this one blue is a curve. At this point, they have the same slope, so it looks like it should continue on, right? If I zoom out, maybe we can see that this is curved, if I zoom out enough. So my red line is straight, and my blue line is really a curve, but at that point we've got the same slope. So it's smooth and continuous. Alright, so if I'm differentiable, my slopes will be the same at the point. If I'm continuous, this point will exist, and we'll get really close to the same y value from the left and the right.
Yeah.
If I have a general limit, then we just get as close to the same y value.
When we have how do you write the function for when to determine differentiable like a straight line? Just like that.
Okay, if you want something that's just continuous and differentiable, we could do something like this: y equals x squared. Okay, for every point on this parabola, we are continuous and differentiable, and we've got the general limit. So all three are true. I can derive this equation at any point, right?
Yeah.
Yeah, so we are differentiable everywhere, and if I'm differentiable, I am continuous and I have a general limit. So if you just draw a normal polynomial function, you're okay for something that is differentiable. So all three are true. Where this gets tricky is if you want two of them to be true. So if I want to be a general limit, continuous, but not differentiable, so that's the hardest one. So now I need to create a piecewise function where as long as I plug it in, I'll get the same y value, but when I derive it, I don't get the same derivative. So I want the same y value from the left and the right, but I don't want the same derivative. So that would be something like this. So let's do... Plus 20, I get... Three is 12. It's not going to work, is it? Reduce this a little bit. Okay, 4x plus 2. Now I've got 14, 9, 18. This should be minus 4. Minus 4, and this one will be 18. Okay, so what I'm trying to do here is I'm trying to make sure my y values are the same for the left and the right. So right now 4x plus 2 will give me 4 times 3 is 12 plus 2 is 14. On bottom, if I plug this in, I've got 3 squared is 9. Plus 9 is 18. Minus 4 is 14. So I've got 14 from the left and the right. So if I want this to be a general limit but not continuous, then I just need to make sure that at the point I've got a different value. So I can make this anything I want. I can make this 0 if I want. And then because that's not equal to 14, I will have a general limit, but I will not be continuous. Okay, if I want this to be continuous but not differentiable, then this one needs to be 14. That way I'm equaling what I had from the left and the right. But my derivative needs to be different. So I can check if I derive these functions, I need to get a different answer. So if I derive the top, I get 4. If I derive the bottom, I get 2x plus 3. So if I plug in 3, I get 6 plus 3, which is 9. That's not the same as 4, so this is not differentiable. So this one is general limit and continuous, but not differentiable.
Okay.
Alright. Do you think you can make one on your own?
So basically the x, it doesn't matter. You don't have to change the number for x, right?
You don't need to. You can make this. You can set this at any point you want.
Oh, then so just the y part that's tricky.
Right. So our y value for less than and greater than whatever point you want has to be equal to have a general limit. Our y value for all three have to be equal to be continuous, and then our slope at the less than and greater than needs to be the same in order to be differentiable. So if I ask you for something that has a general limit and is continuous but is not differentiable, their slope when it's less than and greater than needs to be different, but their y value needs to be the same for all three.
Okay.
Okay.
I think I got it.
I think you do too. But let me know if you have any other questions on WeChat, okay?
Okay, sure.
Alright.
So, Ms. Brandon, the next homework assignment is due on when?
The next homework assignment is due on July 16th, so you have 2 weeks from today.
2 weeks from today?
Right.
Okay. When's the Skype session? Or every 1 week?
So we have Skype sessions at China time. It is 11 p.m. on Tuesday nights, and then 11 a.m. so in the morning on Saturday mornings. So 2 times per week. It's all of my classes though, so sometimes we'll get students from Calc 2 or students from Pre-Calc will be in there as well.
Okay.
Okay.
Saturday morning, what time?
Saturday morning at 11, and then
Oh.
Tuesday night at 11. So some people could only make mornings, some people could only make nights.
I'll just be here Tuesday morning. Tuesday night. Every Tuesday.
Okay, cool.
Okay.
Well, thank you very much for coming.
Thank you.
Before you go, okay, Sehyun sent me this. He told me it was a recommendation letter request, but I think it's a scholarship application. Is this a scholarship application or a recommendation request?
I can't see anything.
Oh, let me zoom
Actually,
in.
Brandon, I'm sorry, but I can't read Korean.
Oh, okay, no problem.
Yeah. I'm not like pure Korean. You can, I can send this to Yuja and then I can let her tell you.
Alright.
Yeah, I can send her now. It's fine.
Okay, let me throw this in the Skype chat then.
Oh yeah, sure.
I don't know why he's sending me the Korean version. I can't read that either.
How do you
Okay. Okay, I'm going to stop sharing the screen really quick. And we'll end that. Make sure this is the right one really quick. Yeah. Okay, should be up now.
Oh, this one?
Yep.
It's downloading. Let me ask.
Okay. So I need to know, is this a recommendation letter form or a scholarship application?
Document. She thought you were asking her last question.